So we've got students at a university, 65% are female, 35% are male. We know that 25% of the females take statistics and 60% of the males take statistics. If we have a random student that takes statistics, we want to find the probability that they are female. So technically what we want is we want to know the probability that they are female given that they take statistics. All right. So Bayes' theorem says that the probability of B given A is equal to the probability of B times the probability of A given B over the probability of B times the probability of A given B plus the probability of not B times the probability of A given not B. All right, so this is what we were talking about in the first couple of videos. This is the total probability of that event occurring. And so we're going to go ahead. B is being female, therefore not B is male. A is taking statistics, and there's no not A, so we don't have to worry about that. So we should be able to just go straight in and use these formulas. So the probability of B, or probability that they're female, is 65, so we go 0.65, times the probability of A given B. So that's the probability that they take statistics given that they are female. That's given to us, 25%. So that B is given that they're female, so 25% of female take statistics, so that's probably the statistics given that they're female, so that would be 0.25 all over. Now that right there is just the same thing as what we had on top, so 0.65 times 0.25, and then plus the probability of not B. So B was female, so the probability of not B is the probability of being male, which is 0.35, times the probability of A given not B. Remember, A was statistics, so that's probability of statistics given that they are not B, which then would be not female or male. So the probability of statistics given that they're male is 60%. And so from there, we should be able to work it out and get the answer using Bayes' theorem. And so it's pretty straightforward, not too difficult using Bayes' theorem there. Okay, if I were to want to use a tree diagram, it would have to be slightly different. We could write it out saying, okay, either I am female or I am male. And so the female would be 0.65, the male would be 0.35, and then my tree diagram would then look like this. And so if I'm a female, there is 0.25% probability that I'm in statistics and 0.75 that it is not statistics. And then for the male, statistics would be 0.60, and then not statistics, sorry, I put that on the wrong side, not statistics would be 0.40. So if I want to find a random student, take statistics, find the probability that they're female. So first I need to find the total number of students that take statistics. Well, the total number of students that take statistics would be this plus this right here. So that's the total number taking statistics. So that would be 0.65 times 0.25, and then add on the 0.35 times 0.60. And then I want to find the probability that they're female. So females taking statistics is just this top one right here, which would be 0.65 times 0.25, which you'll notice is exactly the same thing that we wrote over there. It's just one, we use the formula and the notation that we have for probabilities, and the other one we built using a tree diagram. So we get the same thing either way. just slightly different ways to think about it and approach it. That's it.